So for number 4 on the quiz, we've got to look at the graph of a quadratic and come up with an equation for it. And there are a lot of different ways to do this, but the way I was looking for was to use transformations. And thinking about transformations and how those relate to our equation makes it really easy to look at something like this and come up with an equation. So we're going to start with y equals x squared, right? That would be a parabola that goes through the center. That's our parent function. But obviously this one is a little different. So there's different things we can do to our parabola. We can multiply some number. We can add or subtract a number on the inside of the graph or the equation before it's squared. Then we can add or subtract a number on the outside. So if we can figure out these three numbers, we'll have a really good idea of whatever our equation is. Okay, so let's start with the slides first because those are the easiest. So you can see a normal equation, plain old y equals x squared, would go through the origin, right? The vertex would be at 0, 0, but this one is at 4, 1. So it looks like it's been slid to the right 4 units and up 1 unit. Okay, so we have transformations for that. If we want to slide a function up a unit, then we can add a 1 to the outside. So that's going to be the first thing we add to our equation. All right, you can see it's slid up. Okay, next, we want to move it over to the right. So let me make this a different color. Okay, we want to move this over to the right 4 units because instead of at 0, 1, we want to be at 4, 1. So I can do that by changing the number that's on the inside. So I always remember that plus either takes me left or up. So that's why I had a plus on the outside for up. But if I want to go to the left, or sorry, to the right, I need a minus. So I'm going to do a minus 4 on the inside, and that should move me over to the right. Okay, so we've got our vertex in the right spot now. And we did that by subtracting 4 on the inside of the graph, or the function. So before we square it, we subtract 4, that takes us to the right, and then a plus 1 on the outside moves us up. This still isn't quite right. So there's a couple different ways you can get our stretch factor correct. That's the last thing we need here. So you need to figure out what is this number that we're multiplying by that's squishing our graph. All right, we can see we're not quite to that red graph that we're shooting for. We need to squish it vertically. So we can do that by multiplying by some number that's smaller than 1. So one way you could do it is just to kind of guess, right? A number smaller than 1, that's too small. We can kind of play around until we get it right. Looks like 0.5 looks really good for this one. But other than just guessing, there's a quick way we can solve algebraically. So what I would do to solve this, instead of just guessing and checking, because that's never a good thing to fall back on, you should always have a way to do it exactly. I'm going to take this point, 2, 3, and I'm going to plug it in for x and y. Right, the point 2, 3 is an x and y that fits on this graph. So plugging in 3 for y. We don't know a yet, that's what we're solving for. Plug in 2 for x, and we're going to solve this to figure out what that a factor is. We already know it's a half, but I'm just showing you how we would do it algebraically instead of just kind of guessing. Okay, so we get a times 2 squared, negative 2 squared is 4. Okay, and then we can subtract 1, we get 2 equals 4a. Sorry, running out of room here. And if we divide by 4, we get what we thought, which was 1/2. So our final equation, we can need to multiply by 1/2, we need to subtract 4, and we need to add 1 on the outside to go through all those transformations. So obviously this one's a little bit different than the problem on the quiz. I don't want to give you the answer, but this is how we would solve this. So start with your basic equations, sliding it around into the right place, and then we can solve for that a value to get it the right stretch factor.